See, I'm asleep.
Alright, water's coming on.
I would have gone the water. I could have gone to Kiana. She had to clap. There's some ceremonial. Yeah. Oh.
Hey, we're doing good. We're doing good.
Well, this is the beginning, and then we'll get better and better.
Oh, look, see how it's right over there? Already?
It's caving in over there.
Look, it's caving in right here. It is caving in.
Good,
It
let it.
doesn't matter, it's a pond.
Yes, it's already caving.
Beautiful areas.
Who's had the best one so far, Mr.
Obviously us.
Um,
I didn't expect it to. Yeah, whoever designed this stuff.
Whoever designed this part right here, I don't know what's going on here.
Yeah.
it's gonna just sit. It's gonna be
It's
sick.
going under and it's.
No.
Yeah, but as someone who did design the bridge,
There's a hole right there.
I was gonna say that.
We're flowing, but this is just. What is going on with over here?
Yeah. Why is the water
It's
not?
not like shallow enough. It's like
It's not shallow enough.
it's gonna overflow here.
Yeah.
This is not good.
Whoever designed this,
Alright, so how are you guys feeling about your
Really good.
Not good.
But we're like filling up.
It's a design flaw.
it's caving right
Stop
there.
filling up. It needs to go into this pond.
How about we just like
It's
This
not-
part isn't even moving. Why is
Yeah,
it so
someone-
still? You guys just finished. Can you give us like a free pass?
Dog, you done all this and just let the water was flowing there?
That's the deal, is you can't mess with it after I turn the water on.
yeah,
We stop the water.
Nope. 3 seconds.
oh no, it's caving to here.
That's fine.
Yeah, but this is strong.
All of our rocks. No, it's not. No, it's
It's
not.
always.
I think the bridge is gonna collapse. Oh god, that's caving already.
It's so stagnant. Look at that side.
This is
Yes,
definitely
there's
Hey,
collapsing happening down
That
here.
means there's less erosion there, though. Yeah, because the less the water moves, the less erosion.
Yeah, but we need it to go.
Claire, I like your
Big
pond.
brain move. I don't know whoever.
Or probably.
That would be a good pond if it went. It's gonna fall.
There's a lot. Like,
I think there's about the same amount of water in both of them.
okay. A lot is cool.
Like Dalton,
Oh,
you had a good
oh,
idea, just bad
oh,
execution. You didn't
oh,
make it deep enough so the water
yeah,
got
but
in.
If it came here.
You did have enough.
No,
like
no, I
5
did not.
minutes.
Don't
You all you
They
have to
cut
do
it
is take your
short.
food. You just have to take your food. You don't.
It's such a bad idea. Why don't you
Hey.
not off the back?
I would, but the video would catch me.
It's
not, unless someone
Okay, but how long do they usually last for?
Someone go up.
Someone covers the camera. I've had some that last the whole time.
I think ours is.
Oh my God. Ours is definitely.
I know worse. It's
I don't know.
What happens when what happens when it's
We did it.
house was pretty safe.
Why is the bridge like actually working?
No, it's not. The pipe's like understated. Why is there a rock on top? It's like over there.
This like needs to go back.
Yeah, the rock was a good touch. I don't even know if that'll last.
She can look plastic. Oh, yeah, his eye put it
What if we watch the live stream like all
Yeah.
I'm gonna like wake up at 3 a.m. and I'm gonna like watch the everything in progress.
Oh wait, yeah, you're gonna leave it on.
Please.
In the name of the Father, and the Son, and the Holy Spirit, amen. Bless us, O Lord, and these thy gifts which we are about to receive. And I Jesus Christ our Lord, amen. May God help us remember the needs of the poor. In the name of the Father, and the Son, and the Holy Spirit, amen.
Honestly, I feel like we're rushing.
We did, because we didn't have the last 5 minutes.
Yeah.
So guys, I don't run the live stream overnight. I turn it off as soon as I do.
Seniors, don't forget, you'll be at Bingo Hall by 1 p.m. Please be there by
You
1
turn it
p.m.
back on in the
sharp.
morning.
In dress code and enjoy your lunch.
Oh my gosh, I just thought about it. We should have like reduced the slope. Oh, we should have.
What the heck is
Yeah.
that mean?
We should have
Make it
built
less
it up. Wow.
We should have made it more.
See, we should have not. Who rushed into this? Yeah.
Good idea.
kind of all.
Because I'm having the good ideas now.
I mean, I was gonna give you guys another 5 minutes.
If I was a rush.
Oh, and you not excited really?
Where are the people that decided
You're not
that
that
this was
excited?
wrong?
I was just.
Alright,
I think I would.
We are going to do a flood before the end of class.
I don't know. It's in a blood and go over.
Oh yeah, look at this.
Oh no, it's good. We're good.
But then it's gonna go into
Alright, prediction, this caves in first, followed by that, then this.
This is gonna. No, then it's gonna go like.
It's gonna go.
Alright, guys. Before we flood it, I do want to give you guys a little bit of an explanation of kind of how we gauge floods and how we talk about floods. We do talk about the maximum height of things like the river, okay? But if you're an insurance salesman or somebody buying insurance or something like that, that's not actually what you're going to look at. Insurance is going to work based on statistics, and so you are going to look statistically at how likely is this place to flood.
100%.
Okay.
Wait, in Italy, don't you have to take like the canoe on the river or something?
What? Gondola?
No.
The gondola.
And no, anyways, guys. So, for this, they rate it based on how likely it is to flood. Okay? So, yearly we have floods. Generally, they are fairly small, right?
Yeah.
Okay?
No.
Then they have another step of flooding, and that is a flood that happens approximately every 100 years. Now, this is statistically every 100 years. Guys, you should be paying attention to this. So, statistically, that means we could have a flood of that size 2 years in a row. It's not super likely to happen. Okay, so it doesn't mean that every 100 years we have this giant flood. It just means that that is about the time period that it takes between a 100-year flood. Okay? You can also have a 500-year flood. Okay? So when you go to buy, guys, you are doing a really terrible job of paying attention. All right. So a 500-year flood, similar to a 100-year flood, it's just bigger. Make sense? So the flood that we're going to start with is going to be about a yearly flood, so it's going to be a fairly small flood. Got it?
Yeah.
I think we'll have to wait till tomorrow to do a 500-year or a 100-year
Oh,
flood.
we've already had 2 like 100-year floods in the last year.
Am I gonna get
That's why I
splashed?
said it's statistically. All right, here comes the flood, guys.
This is 1 year.
Oh no. Oh no, it's going into that.
Perfect.
Oh,
That's what we did.
Oh, God.
Wait, this actually isn't that bad.
Yeah, it's
like-
like
Oh no, she's starting to get out. Water's going into here, it's gonna fit in. Our bridge is still standing.
It's about to cave in.
It's
Hey,
just like this
nothing's
middle.
fallen yet.
This is like
over.
this is-
It's getting
And
so
you see what's
wide
like
right here. The bridge is all.
Oh no. Oh no.
It's falling.
Oh,
No. No, it's still standing.
I'm still standing.
Oh, sorry.
Hey, now we can't even
The house
go.
Yeah, now I can't even go.
Let's do it.
No,
It's
the lobster
working.
is in the ground.
has redirected.
The lobster
Hey, we're doing good. You are the second class to have redirected their river, which is questionably disqualification.
Wait,
River
oh, come
also
on.
counts, so.
Come on.
I did it
It's
wrong.
not
It's
water.
You can still walk across the bridge.
It's not
It's
water.
It's dry.
It's a little sloping.
That house didn't fall.
It is.
The water's flowing backwards.
That house looks right now, right
The
there.
water's flowing backwards. You just like.
I'm worried about the lobster. I think I'm drowned.
This isn't the
Dude, this water is going into here.
So what was that, like 100-year flood?
That was a
80,
1-year
20.
flood.
Oh.
Our lobster's like inside of 1-year flood. What's the 500? Is it like all or none?
500-year flood.
Yeah, I think that's the slowest flood that I've done in any class.
No, you just like say that.
Stop disrespecting
Our river isn't even going. It's not even going. Yeah, our river's
Jumping
jumping.
ground. That means it will at least get 2 out of 4.
Alright,
Hey,
I will let this run. The live stream is running.
I say that was a success.
Success.
It's something.
Why do you
You
want
can
to
still use the bridge.
I mean, like, not I found rocks thing.
Still drive on the bridge. I would take my bicycle on that bridge.
For real though, like if I saw that
You
bridge,
invest for it.
I'd trust it. I'd be like,
It's only like a little offside.
This bridge is a high quality bridge. Oh, what was under control? Or otherwise known as called Pharaoh. Yeah.
Have a good day, guys. Why are you not even trying? You get to leave for another one. You gotta at least try. You could have been done by now. You would have just opened it yourself too.
being really loud like humans do.
What? Can I run to my locker real quick? If you're out in here, out in here.
I will not have to learn.
Oh dang.
You want them to live stream.
No, I'm not. I was just saying, oh dang.
And then we.
You did it last hour.
Hey, that was from my locker. You didn't even go to his locker.
I mean, apparently you gave him your code, so that's not my problem.
Get it out.
Really? Think I'm that confident to be able to figure out who wants to go?
Yes.
No, I just. I'm pretty sure you told me. I'm pretty sure you taught me.
It's not like we had no, look at that bridge. That is not a bridge.
I would so go across that. I don't think that's bullshit.
Yeah, the river is harder than the other one.
I was agreeing.
This district's small. He's gonna get last. He's gonna get limited positions.
I forgot that.
Seth Ferguson's gonna be better than Seth. Seth Ferguson.
Next time, even car.
Wait.
No. Friday.
Hyde, Seth Ferguson.
Even car because it was and like the whole time, Connor Adams was in the group and he was keeping score in those feet. So we were like, yeah, there's just two people that cheated their scores.
Why'd you tell the scorekeeper?
Because Connor already got in trouble.
For what? Not involved in round?
Yeah, for signing his signature on a comment.
He cheated too?
Nothing I know.
What match you?
We both shot 35.
35 is in 30s.
Not a kick.
Are they like one hole short or something?
No, this one's better.
Why? So it's 71 straight?
Oh.
Oh, yeah. That's it. It's not.
Why does yours? Just like this.
Guys, why are you messing with the catapult or the tracker?
That's fine.
You still should not be touching it unless it's fire.
I'm sorry.
You're literally holding on.
Yeah.
She did. She said the voice.
Did you get that pen? This is not gonna long. Chapter 24 tomorrow.
I got it.
Alright. E-Hour is doing the river table right now. You guys will be tomorrow.
Wait, congrats. Congrats.
Alright. We are gonna fire catapults today, so if you guys made a catapult, go get your catapult and bring it to your desk.
Oh, snap.
I'm supposed to have a
Oh, Mr. Inarcaro. Yeah, your turn.
Our amazing, elaborate cabinet. Oh, this one is definitely.
All right. Next order of business. Before we fire him, we should pray. Do we want to pray?
Oh my God, this is not gonna have to be bad. Do they have to stand and not have to? Okay.
Nobody wants to pray? Using the dice? All right. It landed on the seat next to you.
Oh, wait, that one or that one?
That one.
Wait, that one. Yeah, I'll pray.
Okay. You should close your Chromebooks for prayer.
We're all looking out.
Anything.
For all those in need of our prayers, we have special intentions from my aunt, some extra special ones from my aunt who started a very aggressive kind of, movement.
Hi, all. Thank you, Father.
Bless her now, bless her secret life. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen. All right, so. If you do not have something to fire out of your household, we'll do this. We're gonna fire them one at a time. So who wants to go first? Okay. You have something to fire?
Don't worry, these are plastics. What do I need to fire from?
You can fire from the desk. Try not to fire out.
Fire?
Alright. Who wants to go next?
Alright, this is me. What? Good. Yeah, I think that was on there. Wow.
I would recommend.
Yes, he gave it to us. It's been in.
They are very curious. Like, it's painful. I know, it is very accurate. It's just that flavor and the texture that maybe just don't go together. Yeah. Actually, once you get used to it and get over the strangeness of it, it's not actually that bad. But. You're gonna fire me? Okay. I figured since you like had it all set up. Oh,
It's just like,
yeah. I'm just. I didn't.
Wow.
All right. Anybody else over here have a pen?
That's about
I mean, yeah, can we get over the walls of the thing with Four drinks. I don't have it.
Maybe $7.
Yeah. It's in the flower. Aerodynamic.
All right. Anybody else over here?
for now.
Alright, who wants to go first over here?
I would say Aiden should.
Nah.
I think Aiden should. I thought she was gonna take it.
Wait, we have the garden.
Alright,
Maybe bring your mom with us, that'd be a lot. Maybe it's just a different
Yeah.
You would be surprised how much this is. And it really is. I don't know why that was your spoiler. That was sad.
alright, Owen, are you the last one?
Wow.
I think a little way better. What was that? I did.
How much bonus do we get?
Over prepared.
Wait.
Oh, they're really
Alright. Everyone in here got more than 5 points.
Wow, congrats, Alan, and everybody.
Alright, did I miss any catapults?
The one, we should buy a Dalton.
Yeah.
No. So I have catapults from Lily, Valerie, Owen, Grayson, Dylan, Aiden, Elena, and Lucy. Correct?
Oh,
Good?
I mean,
Oh, yeah.
So,
Let's not take that, and then have your.
the wind was, we tried to launch it during Dalton's class today, and the wind was actually floating and playing around the soccer ball.
That's the one where I like stuck my head out in the hall.
It did not fire right.
You should record it and put it on.
Oh, we didn't. Wait, we should have an assembly involved.
Yeah.
No.
Just
Senior week.
We're gonna try it again tomorrow, hopefully it'll be less than.
Oh, they should have an assembly where like the whole school comes to watch it and they gotta make.
Set the soccer ball on fire.
That would be impressive.
Yeah, that's a
Actually,
song.
pretty difficult.
You put it in.
Shoot it.
Shoot it.
Whoever catches it can get like.
Everybody has to hold a can of
Probably
gas.
be some people who do that.
And we should have flamed soccer ball.
Alright,
A leaking can of gas.
Yeah, they don't get them all the time.
If you catch it, we'll pay for your house bill.
Yeah,
Plus free Nutella next time I want.
I'm not
no.
thinking this is worth it.
And you get one party race in your physics class.
Two gardens. Even if you're a senior, that's like.
But other than that,
Yeah, man. And if you're great, you get to back up that rule. You have to take it next year.
Surprisingly, can't, but
Like JC was.
Surprisingly,
Did you sign up for it already? Or do you have to sign up first?
however much you hate, I remember when you
and it's custom.
It's like we gotta let each other. Sam Smith is like this like famous artist. Then you got the movie Dude, if it didn't move I probably should have been.
You guys are fine.
I just think it's so hard. It's
Gary, do you have the pulling worksheet?
Wait, how long has it been?
That's an excellent question.
It's been like,
This was from April 19th.
that's been over a day, probably.
That is definitely over a day since it's not even April.
Oh my.
Wait, stop it. Wait, why are you still using good points for it?
Yes, because I'm being nice.
I for real looking.
Do it right now.
I have not given you a referral.
You did give me a referral.
That was just for the end.
Wait, what is this?
This is the worksheet.
I thought this was the
No.
Yours did shoot very far.
Ours
I
is
did give you extra points.
Ours is stinkery.
Oh, this
The-
is me
the-
on my.
Yeah, can we refire and we upgrade?
We're upgrading right now.
Sure.
I don't think our,
Yeah, yeah.
Yes.
I don't think the rubber knob has enough weight.
It's
I
not
got
very
the nut that's back in the box right there. It's like a metal one. Yeah, I'm gonna tell my dad. Like, harder or something like that.
Oh my god. Where's the thing at?
I make sure you look out and try not to fire at people.
Where's the fire at?
Fire at Dylan.
I'd say I'm a partner.
That's plus 44 points.
You said we put a metal.
Where's the
Oh, Dad.
Overall, I think we did pretty well on the rookies.
Sitting there?
Yeah.
Sounds like sin on.
Yeah, Dylan, fire all the way back to last.
Curious as to how we want to go.
Wait.
You put another metal screw in. Put a screw inside it. I have one at home. I found it in my yard.
Well,
Hey, mine. Actual golf ball is so fun. They can
We're going up.
Gary, you have the work.
Not finished. But I do. I
You
have.
have the work, right?
Yeah, yeah, I have.
Okay. If I get it tomorrow, I'm not gonna put it on referral.
Alright.
500 grams versus what?
You wanna look and see what we can do?
Can we find something heavier to shoot than
Really? I didn't aim it at Riley.
I feel like we get
Can we look for something heavier to shoot?
Where I gotta count that?
These might be heavier, but I don't know what they are.
The golf ball?
Well, it's not
it's a plastic.
plastic.
Oh,
I don't know, we should
That
just
was
always
22
do.
feet.
Huh?
With an obstacle.
That.
It's not gonna fit.
Oh, man.
We might have to like
I like that.
put it at the.
Four.
Straight up.
I know.
Oh,
I think I didn't think.
round two.
I'm kind of sick though.
It's supposed to. You should be like this.
Like Miss Green, you play sports? Did you play any sports? You did?
You dance though.
Yes.
Are you a good dancer?
Did you dance here? I did not, I did just classical ballet, so not on the dance.
I can do that.
I mean,
I'm concerned with classical.
I guess good enough that when I was in college and did
My mom
dance
used to do
in
that.
college, I was actually invited to be in the like dance competition.
Oh, so you were like, dude.
I mean, I did it for 12 years, so she wasn't mad.
I feel like I would stay in one position after.
That was fun.
Yeah, and
I have the muscle memory, I don't have the strength. So I can do stuff, but I cannot do it as well or as fast.
What's those magnets with like nails on the front?
So like I still have the muscle memory in my arms, but like my arms get tired a lot. You should show it sometime. There's a new fish. She's the one where they like turn
Just have it like.
You're the one that runs off and they're like,
But I'm not good at
Like, like face up, and then once
You have like
it gets all the way down, it just shoots straight. Big filter.
I thought you did it like a
particularly bad for us doing that.
Just that.
I didn't know.
And what'd be the point?
Oh. I was joking.
I was completely.
I was like dead serious.
Here, I got an idea. Guys, I got an idea. We'll take out their like.
They're cats.
What was with the bouncy ball now? That's what we should have done.
Yeah, things like that is not
So it's just
okay to
little-
do without wax and stuff like that.
Sure, say without that. You don't need that.
Probably your lemons. Just three balls.
My dog.
Oh, yeah, And that's how you want to.
The little one.
How you're like, yeah.
I launched it. Like, that's very bad.
And I found
Just
my
forgot
buddy.
it's good.
That explains everything.
And I almost ran over it with the brand new lawnmower.
You
Hey, it's because my mom, my dad lived outside without knowing me. Or knowing, my mom didn't even know. I threw a dog back inside. Where'd you get that from?
Are you gonna do
So later.
You got Santa's now?
She's taking tomorrow after school. I also have not graded them because I'm trying to get the year labs graded and there's some right now. So, sports recordings. That's my All right,
You think that will go back in bed?
last time, we were talking about these septic pipes, right? Oh, yeah, no, I did already.
Yeah, okay.
We did not do all those.
Wait, what's the golf ball? in
Actually,
there?
wait, what is the
Golf ball is not something we're gonna talk about.
Oh. Yeah, can we?
I don't think I've done
I don't think we did the one direction.
Yeah, I don't remember that one. I don't remember that one actually.
I do remember the one thing, the one you got from like the floor.
Oh, wait, yeah, no, wait, that one.
All right, this one, we filled it up with water. What happened to the water level?
They were all the same.
And they were all the
Except
same,
for the seats.
okay? The zigzag one was pretty much the same. It's just that when it's like in the middle of this, because the water level is sideways, like the top of the water is level with the rest of them, so the bottom of that surface is not. It's just, but it is actually, okay? So, we've got this one, right? Okay, then this was to demonstrate water pressure. It showed that really the only thing that affects water pressure is how deep it is. Yeah? Okay. Then this one, we didn't do that one. I have it, no, we didn't. Ow! He can't do his catapult.
Oh, yeah, you were about to like how much Can I get a bed?
Yeah, I'm still not sure why. Are you like trying to pull it out?
When I was in Hawaii, I was
I didn't have 4,000.
I got me like, all right.
Okay.
Ah! I mean, it works,
I mean, it's really probably the way to seal the we have to seal it, like not strong in the water bottle. That's why it's leaking.
Dude, just appeared on the trash.
It's not very good.
You just walk out there and then
I'm
this is
sorry,
your
water
life
bottle
now.
is all the time.
Swear to God.
I'll know they didn't.
I saw him walk through the gate and I saw him go, turn around and turn back around.
Alright, so you guys don't remember doing this one? You did this one? That's what I thought. Okay. This is the one that I turned upside down while it was full of water.
Oh, yeah.
You guys remember
In
that?
the air, no.
Oh, wait, it didn't happen.
What? No,
Gary wasn't here, so.
Yeah, Gary wasn't here, so.
yeah, I was
Have a lot of
asking.
unconventional
Gary was.
Uh,
Gary's gonna cry for me.
Actually, the first thing I did was sort of
Yeah.
fast, and it won't fill up. So, I think it was on a video.
Profound. I think it's profound.
So if you watch, Edit Hills, the water level does exactly what it did in the other case, right? Water level stays even.
I found that very sometimes.
You know when you say it's like, rip their neck
Miss Green, does bowling like your bird?
What?
Does Mr. Bowling like your bird?
Well, Mr. Bowling doesn't overly dislike them, his wife is not.
Actually, I'm.
You say hey, right?
He said someone.
Actually, I was,
His kids like my birds.
Leo and you.
Alright, you ready? Good. Water's not all over, well, water is kind of all over, but that was. So, alright, is water dripping out now?
Nope.
No.
No, okay.
I mean, there's one.
That was before I was. Alright, to empty this out, how do we empty it out? Oh, yeah, he's about right.
You guys shake it.
If you break the surface tension, it will actually break.
Yeah.
It's like the world.
And I'll-
Record of water.
That it would be very impressive. I don't know, I'm just like,
Well, that makes-
You can just suck it.
No, that's good because it won't do it.
I mean, if you're in a car or something like that, and it's upside down. So, it's the car.
Once you bring it, so. Yeah, yeah. You know, that's it. That's fine. Yeah. How many gallons is that?
Like adjustable.
Oh, that's more.
Yeah, it is less than one, yeah,
Makes it.
it is definitely less than 1 gallon. Okay.
But
It would take a long time.
But like, yeah.
But it's
not.
I'll take the 75.
Yeah, you know how fast you.
No, I would watch it.
Yeah.
Like,
You
you
know
can
that,
back,
what they like-
go in the back
I
of
don't
the
know why
truck,
you
go
don't.
straight
No one
unless
actually
it's silent.
No.
There's a stool in the back right there, you know, the bunch of houses. I didn't mean to. Oh, no, she's not gonna be able to sit down and hold hers.
Oh.
Where do I mean, there's a stool right there.
If it hits you, I may laugh. And make sure you're okay.
As long as you do the second part. Honestly, if it hits me, I'll probably laugh.
I will not. That's all.
You have to break glasses, probably did.
It seemed like you had some. What are you firing?
That's a dice.
Oh, this is how you get a pig.
This is how we gotta pick for,
This is who's gonna pray.
Okay, so I think that one wins.
Hot dang.
All around.
I think yours might be the farthest so far. 'Cause we actually shot the big one earlier this morning and it did not shoot up.
Now, did it?
I think Heidi might have shot it farther than the big one.
Wow, what a performance. But it's raining, Laura.
Thank you, Heidi.
The 2x4 or the 4x4.
Oh, wait, we should talk to Gary though.
I feel like that one might hurt. Alright,
I don't even know what comes to Gary.
so the next thing I want to talk about is some of the ways that we use fluid pressure, like what we have in these pipes, okay? Or in these tubes. That was last. Oh. So we're talking about air pressure and water
That's
pressure.
very good.
We were talking about airplane heads.
Are those the
Okay, not-
today?
Yeah, we never went chocolate on there.
Yeah, I don't know if we're gonna actually make it down there.
We should just do that on.
No idea. I will let you know when they're ready. It should be hopefully by the end of the week. Some of them. So you guys, I think, should already have pressure, right? Yeah. Buoyancy and Archimedes principles were for my physical science class. So we're not talking about those yet.
Oh, you got a different class.
We have what?
What grade is
Sure,
yours?
eight
Just have
now.
a scope.
That's watching the live.
Then what grade is yours? What grade are they in?
They're junior.
Tell them I don't.
Okay.
We have an 8-hour class without that and just like.
Alright, guys. There's some really cool stuff we can do with water pressure. And one of them is the right down. The pressure. You should already have it written down. I don't should have written it down. No. Oh, you don't need buoyancy or Archimedes. Alright. So there's some really cool stuff you can do with pressure in water. I'm going to show you guys a video about this. One of the things that they're going to show you is actually a barometer. What does a barometer do? Anybody know? It does measure pressure specific to that of the atmosphere. Okay? So atmospheric pressure. We talked about how the air is a fluid, right? Yeah? You guys remember that?
Yeah.
So gases are fluids as well as liquids. So the air is a fluid. Fluid pressure works the same in the air as it does in a liquid. So a barometer essentially measures how much air pressure is pushing down on one side compared to the water pressure. It's sort of, how do you spell that? Barometer?
There's not two R's, there's one.
That's wrong. That is wrong.
That looks wrong. I'm sorry, I don't mean to be like that guy, but I'm just.
Are you confident in there being 2 R's?
I was, but now I'm not. Google just for you. Okay.
Oh,
So there is one on. Okay. So yes, there is only one. I was incorrect. Spelling is not my strong. I ain't never trained. Alright, I am about as good at spelling as Mr. Volling is good at spelling. So,
you actually have decent handwriting, man. You have good handwriting.
we can't read, when you can't spell, that's a questionable advantage. You can definitely tell that I can't spell.
Mr. Vaughn has some good handwriting.
Always questioning if he spelled it right or you just can't read it.
I wrote foundation.
Who's smarter, you or Mr. Vaughn?
Depends on what you're talking about.
Just in general.
The IQ.
Like just the
I'd say Miss Green, because she doesn't.
And he does this wise, science wise, definitely. But he does a lot more with like philosophy.
Is he a very philosophical guy?
That's
Is he
what
wearing
Yeah, very
clothes
profound.
on?
That's right now.
Like, when you just want to get kids, like, that's not the right way to do that.
Kick off the show.
Yeah, that's
But he like, it's kind of like that.
It's
It's like, that's not morally right. He's probably like, that's not very morally right, that's not, that was the terrible, whatever.
Alright, guys, so, like I said, we're gonna talk about barometers. Hey, guys. Anybody know what we normally make barometers out of?
Last.
Mercury. Okay, so generally it is some sort of glass container that's holding mercury. And we're comparing actually the mercury, the pressure in the mercury, because mercury is a liquid. It is a metal that is a liquid at room temperature. And so we're comparing the weight of the mercury, because mercury is far heavier than water. Okay, so a barometer made out of mercury can be about this big. A barometer made out of water, you will actually see in the video, and it has to be about 3 stories tall. So, mercury barometers are just a little bit easier to have on your desk, although they are cool. You don't see those very often. Okay, you guys ready to see the video? We're probably not going to be able to finish. We can start. Oh, the other thing you will see in here is very, very surprising. Okay? I kind of mentioned this. You can actually boil water at room temperature without adding any heat. Okay, so you guys know you can stick your pot on the stove and eventually it'll boil, right?
Yeah.
Yeah? We can actually boil water in a different method. Okay? If we had a good enough vacuum pump, I'd actually show you this. Don't know that ours is even good enough to get water boiled. I could probably test that. But you can actually boil water to the point where it freezes.
Actually.
Yes.
How do you?
So, to get something to boil, normally we add heat to it, right? Yeah? Now, there are other ways to get something to boil. One of those is to remove the pressure on the liquid, okay? If we remove the pressure above it, the liquid wants to become a gas to better fill that space. Does that kind of make sense? Okay? But to do that, it actually takes energy with it, because a gas is a slightly higher energy form than a liquid, okay? So, as the liquid goes to boil, it actually is going to make the liquid colder because it's taking energy from it. Does that kind of make sense?
Yeah.
Okay? So you can actually boil it and get the temperature to go lower if you remove the pressure. Okay? You can boil it to the point where it freezes. You have to have a pretty good vacuum pump to do that. Cool. We're not going to see them boil it to the point where it freezes here. They're just going to make a barometer. And when you make a barometer with water, the water does actually boil at the top. Cool?
Could you cook something?
What did I just say about when we remove pressure? Does it get hot?
I was
You need the heat to cook something. Okay? So normally when we have something in boiling water, we're adding heat to it, the water's getting hotter so that at room or atmospheric pressure, it boils.
that was the heat. Cooking it out.
Yeah, it's the heat, not the fact that it's boiling. Now you could actually freeze something if you stuck it in the water and boiled it this way. So you could freeze it, but you would not cook it. All right, you guys ready? It's the same guy that we've been watching. He's got the videos on water and stuff like that. So that's why we've been watching him.
I like it.
Mechanics that plays a role in areas all across our lives. Whether you're designing a water tower for a city or you just want to understand how those upside down pebbles work, you've got to know how to relate the depth and pressure of a fluid.
Hey, I'm Brady. Today on Practical Engineering, we're talking about hydrostatics. I put together this drawing of a few different containers filled with water.
One is skinny, one's a bit wider. This one's kind of like a maze. This one is funnel shaped, and this one I call tanking a tank face. Take a look at these. Pause the video if you need to, and try and think about if you put a gauge at each red dot, which one would have the highest water pressure?
Alright, which one would have the highest water pressure?
All of the funnel. That have the same.
Okay, so are you saying this is the skinny one or this one? Funnel one?
I would say
The same.
Okay,
this is like the extra one.
right. Gary's going with the same.
No, yeah, we don't know.
Anybody else have an opinion?
I find it.
Nobody's going for taking a tank face?
Wait, yeah, I'm gonna tank this because no one else is, but I think it's gonna be,
You think it's gonna be all of them, but you just feel bad for taking it?
Yeah.
Okay.
I'm gonna call.
Alright, you guys ready?
Made a decision? The correct answer is the pressure at the bottom of each container is exactly the same because they all have the same depth. In fact, for a fluid that's not moving or static, the volume or distribution of the water doesn't matter. The only thing that affects the pressure is the depth. But why? You may have heard of Bernoulli's principle, which basically says that all fluids have energy, and that energy can take one of three forms: kinetic, potential, or internal. Static fluids, or fluids that aren't moving, don't have any kinetic energy, so we're left with only potential energy, which is related to the height of the fluid, and internal energy, which is related to the pressure. And this becomes really useful because any body of static fluid will have the same amount of energy no matter where you measure it. Let's pick one of our tanks and demonstrate what that means. At the surface of the water, the height is greatest, and the water pressure is 0. As you move down into the tank, the height decreases, but the water pressure goes up. So there's no change in energy. At the bottom of the tank, we can say that the height is 0, so all the fluid's energy is in the form of pressure. Notice that in Bernoulli's equation, there's no volume, total weight, mass, or distribution. It's just height, pressure, and the unit weight of the fluid that relates the two. Look closely and you'll see that this relationship has applications all throughout our lives. Here's an example. Any city has a grid of pipelines carrying fresh water to all the buildings. Often called water mains, these pipes are under a significant amount of pressure. Imagine if you could tap into a water main with a vertical pipe. How high would the pipe have to go to keep from overflowing? We can calculate this using Bernoulli's equation simplified for a static fluid. A typical pressure for a water main is 60 psi, or around 4 bar.
Fun fact, ours here at Notre Dame is actually really close to that. I have a filter set up back there that has a pressure gauge on it that's filtering water for the saltwater tank. And it is sitting somewhere around 55 psi after it goes through the first set of filters. So it is actually very, very close to 60 psi.
The static head equivalent, in other words, the height of a column of water with that same amount of energy, is just the pressure divided by the unit weight of water. For a typical water main, we find that the static head is about 140 feet, or around 40 meters. In fact, if you could do this at every point in a city and connect all the points, you'd have what we call a pressure plane.
So, in areas where you have a lot of hills, or mountain areas, then you actually have some issues with this. Because what if you have houses that are higher than 140 feet above? Well, they're not gonna get water. So a lot of times, if that's the case, they have to have like backup pumps or a separate system for those higher up houses.
An imaginary surface, almost like a comforting blanket, hovering above our heads, representing the water pressure at any location.
Actually, the other way that this comes into play is in skyscrapers, because there are skyscrapers that are taller than 140 feet. And so if you were at the top of the skyscraper, you don't get water pressure. That's actually why during like when the crew out and stuff, people at the top of the skyscraper do not have water pressure. So, happy day, guys.
Green, I think, I get that.
Yeah, I would have some here. Now we're going to get it around.
Wait, come get the second.
What is the actual like drinking water? How well it's constructed as well as our pipes. Apparently people don't own their guts.
So basically, like, she's in her room and she just saw that his dad moved out and she like fell back in love with him.
It is one
Do we need,
also, we tried to find the catapult earlier and the wind made the sling go around the optimal. So we're probably gonna fire it tomorrow.
that's great.
China, it is.
These are so like really good. Nice.
So we will fire it tomorrow. So we can kind of, you know, talk to this person.
Yeah, I mean, we have to picture, I don't know where we would, we usually take that, like,
We did it in the gravel part.
we should take it out.
Like right now.
No, all you have to do is school. No. I'm gonna learn.
We're gonna do it tomorrow.
Yeah, it's pretty good. Yeah. I wonder what we could have changed it,
I mean, wind's gonna affect it.
no matter what.
And if you're firing into the wind, it would fire back to the wind. So hopefully tomorrow it will be less.
You tried it again with the wind, or
No,
with the wind, yeah, sorry, yeah.
we did it across.
You think with the wind would work, or would it like slow it down?
It would have fired for 60 feet, like,
Okay, it should be working.
because the wind's gonna mess Like I said, tomorrow.
We'll do it.
So it's not that we're not gonna fire it.
But I'm just gonna do it tomorrow, do you have like time limit on the cyclical time?
Sometime in the next year. When it's not a extremely windy day.
It's soccer, I wonder will it really
Yeah, probably. I don't know, it might get stuck in the sling.
When Elton tried to launch it, it get off the, water.
It was not coming off there. But it,
Because of winter was just.
the last one was, I think it did come off on the last one, but the way the wind had it, it made the, like, back of the sling close down around the top of
And like,
And so it went up and then it went straight down.
you look on the bottom, of course, is this what they like not have some curve?
It depends on the catapult.
They're on outlet, like, it should be more straight.
That might help. There was at least once where the rope actually got wrapped around the hook and that's why it didn't fire that time. But yeah. If you guys made a catapult, I would like you to go get your catapult. Unless it's gigantic, I won't put on your desk.
I'm strong.
Um,
I'd say pretty strong. Are you gonna take a picture? Oh.
Yeah, I don't know what happened. I don't know if the remains were too strong because I came in the next day and it was broken.
Yeah, I think it was, and then I like.
Yeah, that's it. Because then you put it down. Yeah, maybe you can get over that. Put it on. Yeah, and then. Yeah. You might want to. Or remain perfect strong. Move it up.
Mr. Rollins might come watch you have the walk.
Ours, mine, Dalton, me, ours. Yeah, just put one of us.
Alright.
Yay! That's that 36 ATP frame right there.
Alright. Before we launch the catapult, we are going to pray. So, who would like to pray? For all those of you who are prayers, there's a special intentions for my aunt, especially today. She's starting a new type of chemo that is very, very strong. Bless our ground, bless us to free them. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen. Alright, so, if you do not have anything to fire out of your catapult, I do have, this fork ball that's very light, so it should fire out of those catapults. But if you have something, I know some people have prepared ammo, that is also fine. So, like I said, you're gonna fire, Dalton and Min tomorrow. It was too windy this morning to fire it well. So, we'll do it tomorrow. Hopefully it's not. Actually, that's a good one. So,
Maybe it's like.
it's less windy, it continues to get less windy over the week. So, if it doesn't work tomorrow, we can try Wednesday, well, you guys are off Wednesday, so Thursday, there's supposed to be very little.
Well, everybody's. Well, I guess.
So if we need to, it's supposed to rain Friday, Monday. So if we can't fire it tomorrow, we will fire it.
Go ahead.
We will fire it at some point.
That team is, say, half the month, in a break.
It's too powerful.
It's too hard. That's true.
I got the cell
Like, when
phone.
you're done school,
I got the cell phone home.
okay. I'll do one year tomorrow. Whatever costs, whatever costs are in it.
Oh, I'm gonna use this one.
Are they go outside for the whole year?
We're in it.
I'll go into it.
And we'll be at the other side. That costs a food. I'm not gonna use this all the way over there. That's just the way. Oh, okay, so like, it's two bedrooms. Directly on your head. We're gonna be using a song.
It's a lot.
What?
It's a lot.
We're not, we're not gonna destroy it.
I'll do it.
All right. We're not going to destroy it. All right. So, pray. Who would like to fire their catapult first? I like
The hook on the end like scrapes the ceiling. The arm is like perfectly enough. Man, we would just take out that. Me and Milton built the stand right there and everything in 2 days, and he did the statue. He was pretty scared. Everyone was, welding that stone right to the.
I mean, I've never used a welding mask to screw pieces together. Kind of increased the difference, but you know.
We broke like two, like, the started. Well, I said, no. He broke with the end of the big 8 screw. So we have like 2 screws that we can't take out. So that's just there now. We can't really take it apart.
After the sun is good, everyone is straight into finals. So that's when
So, yeah, the 17th, we'll have like a big match with the seniors and stuff like that. The 18th, we have one exam in the morning and then the award assembly in the afternoon. And then we have 2 finals. And then Monday, we have 2 finals. And then Tuesday, we have 1.
is it normal?
No, it's, just the final. So it's 8 to noon, and then we get out of here. Alright. Who wants to fire their catapult first? Besides me. You're gonna have to start calling them. You can fire it from your desk as long as you generally try not to. You can, but I'm gonna say no.
Well, nice one.
Alright,
That's pretty hard.
usually the wear
Let's see.
What?
This is what they distribute. Got you. Oh, whoa, reflex, oh my god, that's good.
No.
Gotta get harder than that. I can do it. No, it doesn't work. You gotta get the, what's that, everybody has a little triangle at the end.
Alright, where's the Alright, we have a class working on the river table.
Down.
Maybe that wouldn't happen. Or you can't. Like, don't down, it's not for that. There's no need to, it doesn't go back, right? Down first. Someone in one of our clients, you know, that happens, there's like a hole in their nail, and they put the hard stuff, and he got into the hole, and like got infected. So the guy was like router, like with the hard one to get all this stuff off, he punctured that part. He's infected. Ew. Don't bite your nails.
Put the stuff on as they give you like little kids.
Oh,
Yeah.
Yeah, you need that, so, like, pH, yeah. Like, feet.
So I like buy them like pieces.
Disgusting. Tastes like work.
We're just gonna throw it.
That is,
Yeah, but look, we're like.
that is pretty not good.
There is, I know my grandmother used to have acrylic all the time. She actually ran into some
I do bite my
issues
nails.
with, your fingernails are permeable, and so like, you can have like acid stains.
Every time I hear about this stuff, I remember like.
So, like,
it's like those milliliters
if
shot
you're
up,
gonna
that's
build
like.
up with like oxygen or anything like that, you can go through like your nails and stuff, and also oxygen can kind of get in a little bit. And if you have acrylics on for too long, it's itchy, and that's why it's very likely like.
Was it all the way up, or was it just like in the bow? That's what got it like that long.
Yeah, it shouldn't be after a week. It's like if you essentially put them on and then immediately put a next set on.
Well, what if you better just go, get all that stuff, you like at the doctor's stage, you drill that. You need to drill the little spots.
Hopefully it'll grow back out.
Well, I saw my mom is down. She always they beat them down and it's like it. And then like such a amount of it.
Yeah. You might need to put like antibiotics on things.
Well, I soaked it in, what's that?
Acetone?
Not, I don't know, it's a black bottle.
Yeah.
Hydrogen peroxide.
Soaked it in after I cleaned it up.
Yeah.
But then,
It might just be, so there's probably some bacteria still left in there.
And sterilize the whole stuff. So what they do with sterilization is they have a bone saw, a very sharp bone saw, and they just.
That's not sterilization, that's
My nail.
Oh, usually when it's green, it's too late. You have to take
Did it grow back? Yeah, remember I said this already came off? Yeah.
yeah,
They can grow back.
You know,
um,
why do you think you had it? Why do you think people just, that lady that talked about the driving thing, she had her like, was it bottom here or was it just the,
it's this.
yeah, she had half her head.
So humans do not have enough stem cells in their body.
But
That's
they
why
do
it
it.
seems
They're
like-
all human.
Not necessarily. So that's why like starfish and stuff actually can regrow arms. All of their cells in their bodies are essentially stem cells. And even once they are selected to be a specific thing, they can switch back to something else. Our cells can't do that. So we only have a very, very small amount of stem cells in our body. So
They can basically just like mitosis, like you cut off their leg, it grows into a starfish.
sometimes
Like that's crazy.
you have to get enough of like the central body tissue.
Like, with cutting a starfish in half, kill it.
Probably not.
So if you cut like a starfish, you can actually see microsize. What's the word for mitosis? You can just mitosis, separating starfish. That's crazy.
That's actually, so with the fish tanks and stuff, I've been looking at ways that might be able to actually make enough income to at least pay for like the salt and stuff for the saltwater tank. And one of the ways that I was looking at was possibly breeding anemones. And that's actually how you breed anemones, you literally they'll like essentially heal themselves in 15 minutes. Anyways, that's not what I was planning on talking about today. You guys are next, so that's why.
She's in some doctoring stuff.
Midstream's not green.
I guess if you wanna watch.
How do you say it? You don't- I was
It
not-
didn't hurt. Like, I didn't feel it.
Probably like it.
Oh, yeah, you have to chop it off. It's gonna be
Like,
black.
their needles went from you can see where the.
Oh, yeah, I saw that. Oh, that's that lighting?
Yeah.
I hate that. I actually like hate that. You just,
Putting it through the finger, my brother did that one time.
I don't think it's like.
And yeah, it was not a pleasant thing.
I still don't think I was still really like this. Please, no. Please, no. Dude, it bothered me. I just like get that off and then release that, right? Twist off. Do you
Take
imagine
your
our
fingernail
fingers?
off and then put it back on.
Yeah, imagine our like fingers like twist off, like light bulbs.
I'm gonna change out my fingers for a different finger today.
Yeah, imagine fingers transferring so. I wish you made your customizable like that. You just- Oh, Lego shoes. That's the next GMO. I'm gonna GMO shoes to be 100% customized.
Do like straight up Lego.
Straight up Lego. His hands will be stuck like this.
Yeah. Anyways, so regardless, we had started watching a video last week. Oddly enough, I think, yeah, okay. The class that was right before you, got to the exact same spot in the video. Like, down to the second. So, yes, I have written down that you were at 329 in the static fluids video, and they got to 329 in the static fluids. So, a little odd, but it's over there. All right, so what we were talking about is fluids when they are not flowing, okay? We were just talking about water pressure in our water mains, okay? So we were talking about water pressure in the water mains. Did I mention the pressure in our mains here at school? No? Okay. So I do actually currently have a filter hooked up to the water. It is filtering water for a saltwater tank very, very, very slowly. So if you look back there, the octagon tank is, or actually, I guess it is actually filling up very slowly, but it is filling up. That tank, or that filter actually does have a pressure gauge on it because it is reverse osmosis, and the pressure behind the water actually makes a big difference to how the reverse osmosis filter works. So after it goes through several stages of filtration and gets to the reverse osmosis filter, we are currently sitting somewhere around 55 psi. Every once in a while, you'll see the needle jump. Any guesses as to why the needle might jump? Because it's coming straight from the faucet. What might affect the water pressure in the school? When you use a bunch of water, like flushing a toilet, okay? So if anybody flushes a toilet, you'll actually see the pressure gauge go down, and you actually can see it's such a big jump in pressure because we actually have pressure flush toilets. You'll actually see the tubes that are running in there actually move, which is kind of interesting. I haven't seen it for a while. Most of the time it happens more frequently during lunches. There's a lot more people use the bathroom. But yeah, you can see a little bit of a drop in pressure if somebody else turns on the sink, but sinks don't use near as much pressure as a pressure flush. Cool? Any questions? Okay. So we were talking about our pressure in our water lines. They said that our average pressure is about 60 psi, which is the case here. Okay. Like I said, the filter, after it goes through a few stages, which one of those stages is very clogged up, so that is probably where our little bit of loss in pressure is. It is still sitting at about 55 psi. Cool. All right, what does PSI stand for? Pounds of pressure. Okay, we're gonna go back to this just so that we can at least get the whole idea here. Alright, can you flip this?
Any city has a grid of pipelines carrying fresh water to all the buildings. Often called water mains, these pipes are under a significant amount of pressure. Imagine if you could tap into a water main with a vertical pipe. How high would the pipe have to go to keep from overflowing? We can calculate this using Bernoulli's equation simplified for a static fluid. A typical pressure for a water main is 60 psi, or around 4 bar. The static head equivalent, in other words, the height of a column of water with that same amount of energy, is just the pressure divided by the unit weight of water. For a typical water main, we find that the static head is about 140 feet, or around 40 meters. In fact, if you could do this at every point in the city and connect all the points, you'd have what we call a pressure plane, an imaginary surface almost like a comforting blanket, hovering above our heads, representing the water pressure at any location.
Alright, what would happen if you had, let's say you lived in an area with mountains, right? You wanted to build your house up on top of the mountain, and it was more than 140 feet above the ground, or where the water tank is. What would happen? You would get no water pressure at all, okay? So going up to your house, there would be no water pressure. How do you think people get water up in the mountains? Okay, I mean, you could do that, but you can also still have water, like running water in a house. How level? It can still be part of the city water system.
Use pipe water.
You would have to have auxiliary backup pumps, right? So you would have to have extra water pumps that would sit probably not at 140 feet, but probably right below that, so somewhere around 130 feet above the water plant, just to make sure that you would always have water getting to those pumps. And then you have auxiliary pumps that would give you the pressure you needed to get up to where it needs to be, right? Can you guys think of another place where this might become an issue? Is there another thing that might be taller than 140 feet that we might need water at the top of? A skyscraper. Okay, so skyscrapers generally also have auxiliary pumps that provide the extra pressure to get the water up to the desired height. A lot of times they're at the bottom or towards the bottom of the building. Just because if you end up getting negative pressure in the lines, you'll actually see in the video what happens with that. It is not something you would want to happen in a water line. So it would probably be towards the bottom of the building, and it would provide that extra pressure to get the water to the desired height. Cool. Any questions? Okay. Pay attention to what he says next, because we do actually have something very similar to what is depicted in the picture. Right?
Actually, we do have pipes exactly like this in almost every city. I'm talking about water towers. The height of the water surface in a water tower corresponds exactly to the pressure in the water mains. These are locations where the imaginary pressure plane has a real-life physical representation, and this is why water towers are all usually around the same height.
Okay, so this is why if you are on the city water system and the power goes out, you still have water pressure, right? So if you are in a skyscraper or something like that and the power goes out, you will not have any water pressure at all. But if you're somewhere like Cape Girardeau where we really don't have skyscrapers, if we do have a water tower, and so for the water tower keeps that water pressure in the lines for us. So as long as the power is only out for a little while, at least at the water tower plant, we will continue to have water pressure throughout the entire city. Cool?
This idea that hydrostatic pressure is only a product of depth isn't completely intuitive. Let's look back one more time at the tank illustrations. Intuitively, you might assume that the pressure at the bottom of this tank is much higher. After all, it has a large volume of water, presumably being held up by a very small column of water. And do you really think that a tiny tube with barely any fluid at all can increase the pressure of this tank by the same amount? Well, let's build a tank and find out. Here's the setup. I've got an acrylic water tank with a balloon in it filled with air. I also have a gauge on top of the tank so we can see the pressure. The tank is sitting on the ground outside my house, and I am on the roof with a contraption of my own design, a broom handle with a pitcher duct taped to the top. The pitcher has just a little bit of water in it, and the inner tube is submerged in that water to keep any air bubbles from getting in. It runs down the roof that connects to the tank. This tube has an inner diameter of only 1/8 of an inch, or about 3 millimeters. So the amount of water pushing down on the tank is minuscule, less than half a pint.
Alright, what's gonna happen as he raises that pitcher up above his head? Yeah. It's just a little bit of water. Is it gonna stay the same? The balloon's gonna expand. Okay. So the tube is not connecting to the balloon. It's connecting to the water around.
I would think that when it gets higher, would the thing go lower because it's not that low? Or would the pressure go lower? Pressure get lower because it's at a higher point?
So they're still measuring the pressure at the bottom.
Is the water correlated to how the balloon moves, or is it how the balloon moves?
They correlate. So the water pressure affects the size of the balloon. Right? So as he lifts it up higher, right, we we now have a taller column of water pushing on it, even though it's through a little tiny tube, right? Okay, so based on what we've talked about, it does seem like the pressure should go up because the column of water above it is taller. Does that make sense? Okay, so based on that, it should go up, but it's just a tiny amount of water, right? Okay, so let's see what happens.
As I walk up the roof and lift the pitcher higher into the air, watch what happens at the tank. The pressure goes up, maxing out at about 12 psi, or about 0.8 bar.
I'm Emily's host, founder and head chef of Senorita. Without being able to connect mobily with my customers on social media or through point of sales, we wouldn't be where we are today.
I put the balloon in the tank as an indicator to prove that the pressure did indeed go up. Looking at this tank, it's hard to imagine that less than half a pint of water could affect it in any way. And yet such a small volume was still able to shrink the balloon to almost half its size, just because I gave it some height. So why does this work? Pressure is force divided by area. The force in this case being the weight of the fluid. If you shrink a column of water but keep it at the same height, you decrease the force, but you also decrease the area by the same amount. It doesn't matter how wide or skinny the column is, as long as it has the same height, it will always have the same pressure at the bottom. Being in a tank connected to a narrow tube of water, like in the experiment, you would feel just as much pressure as if you swam to the same depth in the ocean. Now let's take our newfound knowledge of hydrostatics and apply it to a problem that has probably confounded all of us at one point or another. Those watering bowls with an inverted tank. Why doesn't the water come flowing out? If we use Bernoulli's theorem to analyze this, something's not adding up. We have two water surfaces with no pressure, and yet they're at different heights. How can the energy be the same on both sides? To answer that, we need to include the effect of another fluid in the system. Just like animals that...
What other fluid do you think it is? It's your air pressure, right? So air pressure is going to be a big factor.
The bottom of the ocean, we live underneath a sea of fluid as well, the atmosphere. If we include air pressure in our analysis, the math works out just right. On the drinking side, the surface of the water is exposed to air pressure, but inside the tank, the atmosphere can't apply the same pressure. The top of the tank is a vacuum. It has a pressure lower than atmospheric. This difference in air pressure makes up for the discrepancy in energy that we noted earlier. If you expose the water surface inside the tank by, for example, poking a hole, the atmosphere literally pushes the surface of the water back down. But if it's the atmosphere that's pushing the water higher up into the tank, how far can that go? The atmosphere isn't infinite, so presumably there's a point where it can't push any further. A point at which the column of water in the tank has the exact amount of energy as the column of atmosphere extending all the way into space. What if we could build a taller cat hole?
So essentially what we're trying to do here, or he's trying to do here, is balance out the atmosphere. Ladies? So, we're trying to balance out the atmosphere. So we're going to need a column of water that essentially has the same weight as the column of air on the other side. Does that kind of make sense? You didn't know how tall this is? It is actually a constant. The column of water balance out the atmosphere. And that's what it's I checked it. It's actually shorter than a water tower.
I put together a few links of PVC pipe with a valve at the bottom and a transparent section at the top so we can see what's happening. We hoisted this pipe to stand vertically and submerged the bottom into a bucket of water, similar to the pet bowl you saw earlier. I filled up the pipe with water and put a cap on the top. If you know your weather, you might realize what we've created here, a barometer. Once the valve at the bottom is open, this is essentially a balance beam, weighing the column of atmosphere above us compared to a column of water. And it turns out that living at sea level on Earth has about the same absolute pressure as being 35 feet or 10 meters underwater. Theoretically, that's the height of the column of water we should see in the pipe, but it's not quite that simple. When we open up the valve at the bottom, watch what happens. You see that? Lots and lots of bubbles form in the water and the level drops. There's two things happening here. First, water has dissolved gases which come out of solution under a vacuum, creating some air pressure in the top and lowering the water level. Second, water is not a liquid at zero pressure. It's a gas, so the water at the top of the pipe is actually boiling. Unfortunately, I didn't get the height of the pipe just right, so the water level settles just below the viewing window, and in hindsight, it was pretty cavalier of me to get such a small section of clear pipe. But it does reach a point where the vapor pressure plus the water column is equal to the atmospheric pressure outside. And you can tell because there's no water coming out of the bucket at the bottom. There's nothing tricky going on here. You can boil room temperature water just by bringing it to the top of a parking garage. But you can see why we don't use water for barometers. Besides the whole boiling part, this isn't going to sit very nicely on the desk of your favorite meteorologist, which is a totally normal thing to have, by the way. Instead, we use mercury, which is about 13 times as dense, so the column can be about 13 times shorter. And even with the advent of more sophisticated ways to measure it, we still often use units of inches or millimeters of mercury to describe atmospheric pressure today. Just another example of hydrostatics in our everyday lives. Thank you for watching, and let me know what you think.
Alright, so barometer. Actually, I have the pressure today. You see what pressure is? These little sensor things that we got, actually, this one does have a barometer.
Okay. What's the average, or is that?
What you,
What's that thing? With mercury? Is it mercury?
this one has several.
Which one are you using? Which one would you use?
Kilopascal.
Okay. What's the average kilopascal?
Somewhere around 100.
Alright, I'm gonna say, it's pretty cold outside, I'd say like 98. Say 89. I'm sorry. What? 85, that's pretty low.
I think based on the weather, I'm gonna go with 101.5.
I'm gonna be 101.6.
I might be completely wrong. I haven't actually checked the weather at all. Alright. I was way off. Okay.
990.
Okay, this is in bar, not.
Oh, okay.
900 kilopascal.
We crush every Erosion. Yeah, so that thing Erosion is, well, you can get that from the end of the bottom of the ocean. It's just trauma from being under.
I'm still. Okay, we are sitting at 99.
I said, no, I said 98.
96, they want one.
Oh, that means it's very, come on, it's very cheap.
I don't know.
You're
I got the closest actually, so I said 81.
So, okay, guys, do you know why I guess a higher pressure than what it is? Okay, I said a higher pressure because today is a fairly nice day with light fluffy clouds. Days like today, especially when I looked at the weather and saw that the next several days, we have clear weather and increasingly clear weather actually, and slight windy conditions and stuff like that. I knew that we had a high pressure system moving through, because high pressure systems generally bring good weather. Okay, so slightly warmer generally, nice clear skies, things like that. Cool?
Yeah, you said it.
I did. You could have said it in knowledge.
I'm done.
Alright, let's actually go back. I think I have some.
I kept it 98.
For both of them, that would be good.
Absolutely.
Like, yeah.
If I kept it like 98, I just love it.
Yeah. My guess is our pressure is probably gonna go up over the next 2 years. So, we'll see. We can test it again.
We could, I wouldn't mind.
We can check it.
I'm down.
We can actually set this. Let's set this.
You know that, it's, so back in. I did not have that. Where I was raised. Back in ancient China, noblewomen or actresses would have these finger guards, and that showed that they didn't have to do work. It basically made you free pain. So you had long, ornate, like, finger guards. So it's like, it's a sign of nobility.
Okay. Alright, we're gonna see, I have this set to record a point every 60 seconds. And we will see, we should have 8 points by now. We're gonna see how it changes overnight and through the day tomorrow. We'll let it run. Hopefully it'll still work. I really am surprised with it.
Goes on here.
There we go. Okay. So, we'll let that run. Alright. Okay.
Is river table stuff this way? Whatever.
We're gonna actually do it.
No.
No, not, yeah, a week.
What if we did it on Friday?
I'm not doing something in school because I'm on the live stream.
And I will. I'm sure there's gas cold. Cold is, we never talked before our situation. Yeah, even.
Alright, so currently our pressure is not changing, which
Oh,
I didn't think it would be every minute. Unless you got a very strong pressure. So if you have, hey guys, if you ever get a barometer that makes some tools that you can actually use with water, if you don't want the exact atmospheric pressure, you can want the differences. Especially around here in the springtime, if you have a weather front move through, almost all weather fronts are going to be low pressure fronts. And if you have one of the water barometers, I had one, but it got broken. You can actually have the pressure difference be so great from before to after, that it will squirt out to the top. 99.8. I do think based on my hypothesis is that based on the weather forecast, our pressure is probably going to go up until Wednesday afternoon.
Probably pretty good.
So that's my hypothesis. Cause then Thursday, Friday, Saturday, Sunday, Monday, in there, we actually do get some rain moving through, which most of the time is a low pressure. So,
Is the pressure like, put stuff in water in the bottom?
yeah.
So I was just like,
Because high pressure systems are not.
oh, crap.
Hey, guys,
I wanted that guy like that, something else. I wanted that guy.
It's not so much even the way it affects the water per se. it's generally
And that's why.
the, like, change in
I suppose. Tsunami is when I was a kid. When I was in fourth grade. I was in third.
Alright, I don't know why my phone is making this. Alright, so the next thing we're gonna start talking about is what happens to fluids when we completely contain. Okay, so we're gonna talk about pipes and things like that. So we have a flowing fluid moving through pipes. How many day, guys?
I must. Every weekend.
Go ahead, get to it.
I'll try. I'm
They literally had two sentences together in the book.
So, those are fluids like this. Oh, cool.
We're gonna start another one on home and then pedal.
Oh, that is important.
It's a little crooked.
What's that?
So we did like this French. So you know,
Oh, nice.
like you can try it.
Cause I've done one where, it's one of the ones where like, like one of the, not the pillow cover you would put on like your pillow.
Right.
So
like
ones,
this.
kind of, but it has the slit in the center, and so it like closes around the pillow and stuff. Yeah.
Cool.
Those are kind of fun. Cause you
I
fold,
thoroughly.
you fold the, fabric almost like a letter, and then you just sew the sides.
That's cool. Okay. And this was like a French thing, so like you like the
French seams are nice.
Yeah.
They're really good for craft.
This is weird. Honestly, though. I was like, this is kind of
Yeah, you sew that for first.
Actually, no, I think that changed.
But everything
Says
is
if
done
you
all the
set
time.
conditions, all the time, you
And
get
you
the
can
other
wash
one.
it and all sorts of fun stuff like that.
Death. Yes, bush.
Why are you threatening death to a
No.
Who knows?
It's death, comma.
Because he's dangerous.
No,
This
it's
is
death,
somebody actually touched.
comma, and Joshua Bush.
What?
So it's not even related to
Okay.
the previous
Thomas, what are you
statement.
even talking about now?
Apparently, he's not threatening death. So we're.
Thomas, are you threatening to kill him?
No, I said death, comma, then Joshua Smith.
I mean, if you're trying to give me death threats, it's happening.
No, I'm not trying to, I was just saying.
Love a lot
yeah.
over there.
Because we were in watch JFK get shot.
You've done assassination.
Because we were in watch JFK get shot last hour.
Their bridge did not lie.
That's fine.
And it's.
500-point headshot.
What?
500-point headshot.
Where's
Yeah.
everybody else?
Blake and you were with me in weight.
Dementia.
I saw one, right here. They didn't look the other server. Now at least have two servers.
We can finish the collection, we just need the last donation. Let's just deal with the bridge.
They put all the rocks over there.
I don't think that's cool.
Hey guys, do not touch the river cage.
Good thing you're about to say that, which means I was about to touch it.
Always gotta take the scenic route, come down. Little cruising, never hurt nobody.
Thomas, you just recorded that, by the way.
He was literally coming around. Okay. Schittenberg died.
Okay, so
gonna rush.
Do not
They,
miss
they're
your
dying,
meeting.
they're on the verge of dying, they're fine.
They're not gonna die.
No, I think these people will be fine.
That's fine.
I'm worried about them. Still flood right there. Well, they should be good though. They got some rock. We tried to people on the bridge are definitely 100% going. There's no hope of survival.
I spent $60 for one monster, my singing monsters, but it was worth it.
Thomas, you should not drink monster. It's really bad.
No, I said my singing monster, not monster. I don't drink caffeine.
Understandable.
Stop it. What? Stop. I'm talking about the game, My Singing Monsters. I spent $60 on one monster just so I can get it out of the way so I never have to deal with it again. I got the Woodland Drumore. Don't touch it, Thomas.
Alright, guys, you can come sit down.
I think I have to mint it because I don't remember asking Benson.
Here, Donna. The dash. I'm sorry, Bill Gates.
Bill Gates died.
But Bill Gates,
One of the KKK leaders died. And also the woman who ratted out on it and died. Rick Bozo.
Wait, Thomas, you support the KKK?
No, but one of their leaders died at age 77. And also the woman who ratted out and Emmett Till also died. So Rick Bozo.
That's
Rick
I was just
Bozo.
gonna say that's a good thing, but certain death is used for
Rest in hell.
I mean, no, it's not the.
Alright, guys.
Okay, I don't think death is something that is good. But it's definitely not something where you're like, oh, let's freaking go. That guy died.
Let's go!
You don't have to wave at your cake, but like,
Legacy! Legacy! Let's
but you still die. That's not like, except
Do you get fully canceled?
except you could be in heaven.
All right.
A million times better than that.
It landed on 16, which nobody's thinking.
True, but like, still you die. Your objective is to survive.
Oh! Alright, it did land on something.
Somebody this.
Me.
It was me.
Over there?
It was over there, but it was not John.
It was Joe.
It was Joe again.
No,
Alright, so let's come with prayer.
Thomas, we're praying back now. It's time for Jesus.
For all those who need our prayers, for some special intentions, an extra special one for my aunt. She is starting a much more aggressive form of chemo. Blessed art thou, blessed is the fruit of thy womb. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death.
Why do you have like a laptop on?
So, if you're coming toward the like, so the aggressive.
Bro, where can I buy one of
last
those
stage
things?
came out where.
It's called Walter White.
So for her, this is a planned treatment they have planned on with the cancer that she has. They're hoping, the plan is going according to plan as far as I know. The first few stages of chemo were to stop the growth, slow it down, and hopefully start to kill it. And then this is that final push to hopefully completely kill the cancer. If not, they are going to hopefully remove it after she's well enough after the chemo.
Is chemo just one of those things just like, you know, other, is it just like the sickness and stuff like that?
So essentially what chemo is injecting your body with a very calculated dose of poison. So it is enough to kill the cancer, but not enough to kill you.
But still, I'm sure there's people saying, alright, guys, I
Yeah,
have to
no,
tagline
it's
for my,
supposed to be very
Run for
painful
my
and,
president.
I mean, it makes you lose your hair, all sorts of stuff like that.
didn't it lose his teeth too?
Guys, I have two statistics I'm
That's
using
not
for my run for
Weight loss,
campaign.
hair loss.
I mean, So from what I understand, it makes everything taste very metallic, so you just don't want to eat.
Guys,
Is that a permanent side effect or is that just temporary?
I don't think it's from.
guys, I'm campaigning for a student body.
I know some people, when their hair grows back, their hair is actually like
Number
curly
one,
and straight
the
from
drum
forward,
crash.
things like that. So it does strange things to your body.
And number two.
Like I said, I would imagine
Damn
where
people
it's like,
quit before they get big.
to go.
It's not. That's why they like only use it in a situation where, like, if they did not do something, you would have to say.
So is radiation like the final stage?
No, radiation is different, and especially with the targeted radiation that they can do, it generally is slightly more gentle on the body. So I think one of the common ways that they do it now is they give you chemo, they then remove the tumor, and then they radiate the area. So if there's anything left over, then you can then, fill that. I think the general procedure. They found that different cancers respond differently to different chemos, different radiation, things like that. So. Alright, guys. Do you guys remember what we were talking about last Friday?
Buoyancy.
We were talking about buoyancy. What was the specific thing we talked about?
Our committee's principle.
We did talk about that, but there was a thing that uses that we had talked about. Right?
Barometer.
You guys were asking how they work.
Barometer.
No, we talked about that.
That's one, I bet one could do it.
I'd like to apologize for these.
We talked about boats. What did we talk about after boats?
Golf balls.
Buoyancy.
We did talk about golf balls. We did talk
dams.
about,
Buoyancy.
what was it?
Buoyancy.
Dams, I think was before. It was
Last
buoyancy,
thing we did.
but something similar to a boat.
Oh, a barge? Or just no?
No, we did talk about this, but no.
Submarine.
A submarine. Okay. So we are gonna talk about submarines today. We're gonna talk about how they work. Just because we're talking about submarines, we are also going to throw in a little bit of nuclear stuff as well.
You're gonna watch that October in this class, is what you're saying?
Thomas, I think those noises are very inappropriate for us, and I.
All right, you should close your Chromebooks to watch the video.
Mine
That is very.
You can still close it. Closing it does not mean that it's not broken.
It's broken.
Yeah.
It's broken.
Oh, she's not even on her last leg.
All right. So we are going to watch videos on submarines. This first one is going to talk about generally how they float and sink. So, you know,
A good submarine was like a,
this section of desks is a lot faster than that, just because people want to walk.
Somewhere in the world's oceans, around 800 feet down, you'll find one of the most dangerous vessels ever made, the nuclear submarine. Only 6 nations are confirmed to have them: the US, UK, Russia, France, India, and China. Unlike regular submarines, nuclear ones are truly enormous. For example, the Ohio class, operated by the US, is 170 meters in length with a displacement of nearly 19,000 tons. To put that into perspective, the Statue of Liberty is only 93 meters tall. On the surface, submarines are very similar to all other ships. As they slip beneath the waves, however, there are some very interesting and fascinating differences that we need to know about. Before we dive into that though, let me tell you about this video sponsor, Conflict of Nations. Conflict of Nations is a free online PvP strategy game that Firstly, most obviously, there are huge implications in terms of buoyancy and stability. With a ship, you just need to make sure the underwater part of your vessel displaces enough water to provide buoyancy to keep it afloat.
So that's what we're
Submarines, of
talking
course,
about with
are a little
buoyancy.
different. On the surface, just like a ship, the hull needs to displace enough water to provide positive buoyancy, but it also needs to be able to sink, so you need to be able to increase its displacement to make it weigh more than the water it displaces. It's actually quite simple. You just flood some ballast tanks, making the vessel heavier and less buoyant, basically so that it sinks. That's great for going down, but then when you're deep enough, you need to be neutrally buoyant instead. You want the submarine to weigh the same as the water it displaces, so that it neither floats nor sinks. Again, it's quite simple. You just pump out a little ballast water using compressed air from cylinders. Done precisely enough, you can make the submarine weigh the exact same as the water it displaces, making it neutrally buoyant.
Alright, so, question for you guys. They said they're pumping the water out with compressed air tanks. But if they got the air on board, why isn't it making them less dense or more buoyant? Okay, so they're filling it up with water, right? To make it more heavy, more dense, yeah, so that it can sink.
Yes.
Everybody got that? Okay? Now they're trying to make sure that this water level is exactly what they would want, to make it the exact same weight as the water, or exact same density as the water, okay? To adjust that or fine tune it, they use compressed air, right? So they take the air, they pump it into the containers that have the water in them, the ballast, and that changes the water level. Makes sense, right? Okay. But, guys, if they have those tanks of compressed air on the ship, why is that actually changing the density if it's already on the ship? Sort of. It has something to do with the pressure.
Because the pressure mixes with the
No.
Wait, how low?
It doesn't matter. Alright, what is the factor that actually makes something float or sink? We talked about this. Density. Okay, so density is what actually makes something float or sink. If it has a higher density than water, it's gonna sink. If it has a lower density than water, it's gonna float. If it's equal to water, it can go wherever it wants without any resistance really from the buoyant. Does that kind of make sense? Okay. So, the third one, that's what they're exactly tuning the submarine to do.
Oh.
So, if you compress air down, so you put it under really super high pressure, does that change its density?
Put it under high pressure.
I mean,
Yes.
what?
So, okay, density is just how much stuff there is in a volume, right?
Yes.
Okay? So, if we take something and we start pumping more and more and more and more air into it, right? We're increasing the density because we're putting more air in that cylinder, right? So we're pumping more and more air molecules into it. That is putting it under higher and higher pressure. So if we have a cylinder that can handle a really high pressure, we can actually get it to the point where, one, we can get it to the point where we have liquid oxygen, which has definitely changed how much our density, right? Yeah. So liquid water, much higher density than gaseous, not liquid water, sorry. Liquid atmosphere, so liquid nitrogen, liquid oxygen, things like that, much higher density than our atmosphere. Yes.
I drink it on an average per day.
What would happen if we drunk liquid?
It would not be pleasant at all.
Oh, good.
God. One, so you guys know dry ice is really cold, right?
Yes, it costs.
Okay. Liquid oxygen is substantially colder. Okay, so dry ice I think is somewhere around, let me double check this first. I think it's negative
Dry ice
20
is really
Fahrenheit.
good because once it gets to a certain consumption of like cool water or something like that creates, I think methane or something. And that's how like two Russian, and that's how just like one video on YouTube that exists now of these Russian people like trying to celebrate someone's birthday. So the guy.
Alright, dry ice is negative 109.
All into the North Pole and then go in and immediately die.
So it's supposed to have a good conversation. said dry ice. That's a relevant story.
Okay, so dry ice is negative 109 degrees Fahrenheit.
Yes, that is really. I would know, I've been in negative 1,000 degrees, weather.
That's not fun. Liquid nitrogen, so remember dry ice, 109. Liquid nitrogen is negative 132 degrees Fahrenheit. Okay, liquid oxygen is just a little bit warmer than that.
How cold does it have to be to make people instantly turn into like an ice sculpture?
Was that pretty
So liquid nitrogen, negative 320. Liquid oxygen is negative 297.
Are we just gonna miss what Juan just said?
I did.
Would you say one?
Yeah,
mine
Can you survive a nuclear explosion
I'm
instead
sorry.
of walk into like instead of Indiana Jones?
That's
It'd be better than not. Alright, guys.
Sesame goes green.
Guys.
It's where Neil's father's from.
Hey, guys.
It's where
Hey, guys.
Hernandez and Frozen. Like,
Guys.
problem.
Guys.
Yes.
Alright. So, yes, we can have liquid oxygen. We can actually have solid oxygen as well. I worked in a lab where I was dealing with liquid helium. Liquid helium is 4 degrees above absolute zero. When we would put stuff down in there, some of the atmosphere would actually stick to it. The helium, was so cold that it would actually solidify it. So when we would pull it back out, there would be like solid oxygen and nitrogen on our tube that contained our circuit. Solid oxygen is a very pretty pale blue color. So, but yeah, it was really kind of crazy when it would melt and drip onto the floor and then just like skitter across the floor and stuff.
How do you clean that up?
Don't-
It turns into air.
Yeah. It warms up
What
almost
if we just
instantly and
freeze
just
all the
becomes
Earth's oxygen?
atmosphere.
What if we froze all the Earth's oxygen? How much of the Earth would that be able to fill up if we remove all the water, but then fill up all the Earth's oceans?
I don't think it would actually fill all of these oceans.
Yeah, but like, how much of it? Like 1/3, like 3/4?
Because our atmosphere is only like 20% oxygen. So,
Well, what if we took the entire atmosphere?
like, we're talking probably, I'm not sure because I've not done calculations, but if we just did oxygen, we're talking probably like, Great Lakes sort of
What if we
size.
took like every single thing in the atmosphere, like everything, and then turn that into like liquid?
It's still not gonna be, it's still definitely not gonna fill the ocean.
So it's better to become mergers. So when the atmosphere gets destroyed, you can just drink water instead.
So breathing other gases.
Anyways.
Yes, we are.
Most of our atmosphere is nitrogen,
They're mostly breathing natural.
but there's enough oxygen for us to like take in and use it.
So wait,
It's actually a problem for us if we breathe like pure oxygen. It can be like, I think it's called oxygen.
So what about that one,
It was in the diving video.
Oh yeah, oxygen narcosis. That's when you get the bend.
No, that's the pressure.
carbon dioxide.
Oh yeah, no, oxygen narcosis is when.
But what about that one product, it's like in a can and you like breathe it in, it's just oxygen?
You mean the
Yeah.
borax? Are you talking about the borax?
So, I mean, that's probably just pressure. So we were talking about liquid. Most submarines are not gonna have liquid oxygen on them. Now, if you have like a spaceship or something, then yes, they probably will. Just because you've got a much more extreme situation. In a submarine, you can still come up to the surface. And they have other ways to produce gases that you'll see in the video. So, anyways, they are getting that pressurized gas. That pressurized gas, because it is under pressure, is a higher density. And so when they release that and it becomes a lower density and you push the water out pretty easily, it doesn't take a whole lot of pressure to push the water out. They actually can become neutrally buoyant even though they have that pressurized air on board. Does that kind of make sense?
Let's do it, answers, you read more like.
Read medical marijuana.
That's what we're doing right now.
What?
What was you were 5% off and then 95%?
I'm not.
You would probably be able to survive for quite a while. But it would be very
You know what I
similar
mean?
to like if you went to the top of a mountain or something like that. So you would feel very short of breath, you would not be able to do very much. And it would be much, much more likely for you to pass out than.
Have you ever seen videos of animals on weed, like random animals?
We're not talking about animals on marijuana. Alright, back to our video. Now that we've talked about where we're getting the air from and things like that.
So that deals with the buoyancy, but what about stability? After all, a submarine still needs to remain upright when underwater. Remember how a ship uses form stability to stay upright? This just means that the shape or form of the hull provides a righting force whenever the ship leans over slightly. The underwater shape changes, shifting the centre of buoyancy, separating the force vectors, creating a moment to right the ship. This is how, counterintuitively, the centre of gravity can be above the centre of buoyancy. A submarine, however, can't do that. When it's fully submerged, its underwater shape remains constant no matter how far it leans over. Its centre of buoyancy doesn't move. Instead, you have to rely on keeping the centre of gravity below the centre of buoyancy. Your stability is provided by the force of gravity and the force of buoyancy pulling in opposite directions. Underwater, it's easy because you just make sure the heavy things are placed low down, but on the surface it can be a little harder. Think about it. As the hull emerges from the water, the centre of buoyancy drops lower down because it's just the centre of the underwater volume. If you let it drop too low, it might go below the centre of gravity and the submarine would just flop over. This is why submarines appear to float really low in the water. They need to keep the centre of buoyancy above the centre of gravity. So we've now dealt with buoyancy and stability, but what about navigation? We've already said that on the surface, submarines can do the same as any other vessel. You can take bearings of navigational features like lights or headlands, you could use a radar to measure distances, or you can just use GPS to get an immediate satellite fix. As soon as you disappear below the surface, however, none of that is possible. Instead, you need to try and track your movements since your last known fix. The system that does this is known as an inertial navigation system. It uses a collection of accelerometers and gyroscopes to calculate the vessel's movements and keep track of its location with reference to the last known position. Obviously, over time, positional accuracy reduces, though if you're in the middle of an ocean with nothing for hundreds of miles around, it really doesn't matter. The only other option might be to use sonar or visual markers to try and find your way. Of course, visual markers are fairly useless underwater because it's so dark you can't actually see anything. This is why recently the USS Connecticut apparently ran into an underwater mountain. They just didn't see it. So what about sonar? Well, that would immediately give away your position, so that's actually a non-starter too if you want to operate unseen, as most military submarines do. Of course, if we're saying that sonar is so loud that it gives away your position, what about the submarine's engines? Well, this is another interesting fact about submarines. They're actually powered by electric motors, so they can run almost silently. I know you always hear about either diesel or nuclear submarines, but that's only referencing the source of the electricity. Diesel submarines come to the surface to run their diesel generators and charge their batteries. Nuclear submarines have a mini nuclear power station on board to continuously generate that power instead. The electrical power drives not only the propulsion electric motors, but also the rest of the submarine systems. I'll talk about everything, including the navigation systems, the freshwater generators, and even the oxygen generators. Remember, to stay submerged for extended periods, the submarine needs to be able to generate its own fresh air for the crew to breathe. You can use scrubbers to remove carbon dioxide, but you also need to add oxygen. Of course, the vessel itself actually has a limitless supply of oxygen surrounding it. It's just that it's bonded with hydrogen in the form of water. To separate it out, you can use a process called electrolysis. Just pass an electrical current through two electrodes submerged in water, H2O, and you will get oxygen produced at one and hydrogen produced at the other. Of course, as with everything, it's not quite as simple as that. If you attempt electrolysis with seawater, you'll actually produce chlorine gas because of the salt or sodium chloride in the seawater. You don't need me to tell you how dangerous chlorine gas would be. So, you need to make sure your oxygen generators are fed with fresh water. Fortunately, the submarine needs to have freshwater generators for drinking water anyway, so you can just use some of that for electrolysis as well. There are plenty of technologies that can create fresh water from seawater. Evaporators or reverse osmosis systems are the most common, or you could simply have a load of fresh water in storage tanks. With a large enough fuel supply, like a nuclear reactor, submarines can actually generate almost everything needed to sustain life. The only thing it can't make is food, which is why the food supply on board is actually the governing factor when it comes to extended deployments. And that brings us to the end of today's video. Again, a massive thank you to today.
Alright,
Go for free. Blood Russia.
alright. So, there's some interesting stuff in there. You guys now know how they sink and float, right? Okay. Alright. I wanted to show you guys this one. This is how you can make your own submarine if you wanted to. I did not make one.
We're building one, boys, we're building one.
Yes, it is a real submarine, but you wouldn't fit on it.
We're building one, boys. Guys.
So the points make it heavy enough overall that it can sink, even when there's a little air. So as they fill that, there will actually be water, just like there is water in a submarine, in the bottle. And so as they fill that balloon, it pushes the water out, just like we saw, they would be pressurized air to push the water out. It doesn't actually increase the force of gravity, it just increases the Alright,
Let's go
you
with
can
that.
actually make it neutrally buoyant. They don't show you doing that. It would be fairly difficult with something like this, but if you made it neutrally buoyant, it would just kind of float in the middle of the water. So. Alright, I do have one other video on submarines. This goes into a little bit more how the, like water purification and stuff like that works. Cool? I figured you guys might like watching this.
This is the Typhoon class submarine, the world's largest submarine ever built. It is 574 feet long, 76 feet wide, and 38 feet tall.
Alright, so this one's 570 feet long. Do you remember how long the one in the previous video was?
Oh my gosh, I can do it.
It was about 170. So this is 400 meters long.
That's in feet, this is the other
Oh,
one.
was it
using the metric system?
Maybe it was 40 meters.
For example, the Ohio Cross, operated by the US, is 170 meters in length.
No, it's 170.
Metric
I
ton.
thought it was. This one is 570, so it's 400 meters long. So substantially.
For comparison, here's the size of a person. This submarine weighs a whopping 48,000 tons. That's equal to the weight of about 34,500 cars. These submarines can be capable of launching nuclear warheads underwater, the weapon system that can burn the whole continent to the ground. These submarine cruisers become the most powerful weapons, a banner of Soviet Navy power and a symbol of Cold War fears. Today, we are exploring the legend of nuclear leviathans. The Typhoon-class submarine is able to accommodate a comfortable living facility for the crew of 160. It can stay submerged for 120 days in normal conditions and potentially more if deemed necessary. The Typhoon-class submarine is of the multi-hull design with 5 inner hulls. These are the 2 main long-pressure hulls.
You should go join our crew today.
It is a Russian submarine.
There are 10 compartments of each pressure hull, a total of 20 compartments that house the crew room area, restroom, kitchen, gym, reactor compartment, turbine room, pieces of machinery, and all other living facilities. This is the torpedo hull. This compartment served as a torpedo handling area with automatic torpedo launching units. This is the control room. This compartment is the brain of the submarine, which contains equipment for steering, diving, servicing, and other submerged operations. There are several noteworthy stations within this compartment. Submarines are designed to stay underwater for up to 3 months at a time. Well, all of you know there is no oxygen underwater, but how? How do submarines keep more than 100 people alive underwater? Let's understand how to create breathable oxygen on a submarine. There are 2 ways to create oxygen. The first one is electrolysis. This is the machine that creates oxygen, called an automated electrolytic oxygen generator, or AEOG. This apparatus contains positive and negative electrodes. These electrodes are immersed in purified seawater, and a chemical called potassium hydroxide is added. Then electricity is transmitted to these electrodes. Then the water is separated into hydrogen and oxygen gases. The positive electrode gives off oxygen, and the negative electrode gives off hydrogen. Then these oxygen and hydrogen gases are pumped into these pressurized tanks. The breathable oxygen is circulated around the pressure hulls through pipes and air vents. Oxygen is periodically released throughout the day at specific time intervals. These systems produce more than 4,000 liters of oxygen every hour. Now, hydrogen is then released overboard. The second method to create oxygen is burning chlorate candles. This is a chlorate candle. It's a cylindrical chemical oxygen generator. This contains a mix of 2 main chemicals. One is iron powder and another one is sodium chlorate. When they burn the iron, that creates heat, and the heat from the iron oxide is liberating oxygen from the sodium chlorate.
Side note, they did not give you the right chemical formula for that, because if that's the case, then you just have iron, sodium, and chlorine. You don't have any oxygen in it. So if you notice, he said chlorate, not sodium chloride. So 8, we didn't talk about how you name chemical formulas and stuff like that. 8 is a suffix that means that there is oxygen. So my guess is what the reaction that's actually happening in here. The iron is bonding to the chlorine and making straight chloride. and then it's releasing, the sodium, which is not a gas, it's a metal, and oxygen. And so that's why this produces oxygen. Cool. Ferric chloride is not overly toxic. It's useful for several different things.
This method is secondary. It can be used if they ever lose power for whatever reason that required no electricity or other external power source. The solid oxygen candle is in a very small volume, but it can create a tremendous amount of oxygen. This is also used in a spacecraft. Typhoon's propulsion system is powered by nuclear power. Some of the submarines are diesel-electric engines. This diesel submarine can travel a range of only 14,000 nautical miles before it needs to refuel. If you are running each type of submarine with 200,000 horsepower nonstop for 1 week, the diesel engine would require 5 million liters of diesel fuel, while a nuclear submarine would require only 4 kilograms of enriched uranium.
Alright, this is why nuclear power is so, trying to think of the right word. Definitely OP. So, when we are burning something like gas or coal or anything like that, we are only burning it and releasing the energy stored in the chemical bonds, right? Which is a decent amount of energy. You can definitely produce a fair amount of energy for that. They were saying the sub's going 20 knots straight for a week. That is a long distance that the sub would travel, right? So this is actually fairly high efficiency, but you're still going to use a lot of gas. Does that make sense? Right? With nuclear power, what we're doing is we're not only harnessing the power in the chemical bonds, we're actually harnessing some of the energy stored in that weak force. Remember we talked about the weak force? Yeah. The weak force and the strong force. We're actually taking some of that energy and that's being released because we are breaking the atom apart itself. And so we are actually getting to the point where we get some of the mass, which is super dense energy storage, turning into energy, right? And because of that, it releases so much more energy per kilogram, and that's why we get this vast difference in weight versus our gas that we're burning.
How big is the force right now? You would put that in your hand?
Well, one, with that, you are talking about uranium, which is more dense than the weights that I have back here. So it would actually be smaller than the weights I have back here.
You know, there was this one science kit for like kids that used to sell like, there was this one science for kids that sold like uranium with it. I don't think the US government ever found out how this like kids company actually got their hands on an actual ton of uranium and just started putting them in like these kids' science kits. But like that they proceeded to kill off a lot of people because they played around with the uranium in their hands like
If that was like, okay.
Oh, what's this? What do you call it? The old stick?
Uranium, could you put it in the?
Radioactive food.
Could I put it in the storage room and we'd be safe?
Or let's say you put it into the room right down here on the right across from the computer.
So room 508,
Yeah, the conference room. That's where
we
you use it.
for one, but,
I've never really seen it. Like you put it down there.
in here, we would probably be pretty okay. One thing with radiation is it's not just your exposure to it, it's your length of time of exposure. So between there and here, we've got a fairly big distance, so like just 1 kilogram of uranium, not gonna be too horrible. We also have 2 concrete walls. And so concrete is actually reasonably decent. It's at least better than like a wood frame wall or something like that.
We have lead walls.
Then we'd be fine.
Alright,
anyways.
Just cover your, just don't put lead suit, so when you're rusting the try to do rust, you're just safe.
Lead's pretty uncomfortable.
That's not how it works, man.
Does lead
You know, it's
set
also
off radiation or does it just not go through? It's like
Lead is
complex-
extremely dense, and so the radiation cannot travel through it very well.
It's not like it has sucking it up then or?
No, well, it just stops it.
No. So where does it go then?
It's just kind of stuck in the lead.
Oh, so
So what makes radiation dangerous is the speed at which it's moving and the energy that it
it's
has.
like a.
So if it goes through lead and it just runs into all of these lead atoms, then it just,
It's like blowing smoke into a wall, the smoke just dissipates away. Yeah, but smoke's still on the wall though, so if you gotta assume when you on a street, sorry.
the outside of the suit would be covered in.
Oh. What if you put it in water?
The water would be.
Okay, what is a safe way?
So what if I made, so can you make fire radioactive, huh?
Yeah.
Alright, I'm gonna go sell that to the US military.
Alright, guys. Let's get back to watching the
Use it for their next bombing run.
One of the main advantages of nuclear-powered submarines is they do not require refueling. When one of them enters into service, it will be commissioned with enough uranium fuel to last more than 30 years. The Typhoon-class submarine is equipped with 2 pressurized water reactors. Let's see how these nuclear reactors work. This is the reactor vessel, which contains the fuel assembly tubes. The fuel is naturally occurring uranium. Uranium is a radioactive chemical element that occurs in most rocks in concentrations of 2 to 4 parts per million. And it's also seen in seawater that's processed into small pellets and sealed into metal tubes, which are welded to form a fuel bundle. Typically, more than 200 of these rods are bundled together to form a fuel assembly. The energy production process begins with the fission of uranium atoms inside the reactor core. When the nucleus of a uranium atom is hit by a neutron, it splits into 2 and releases 2 or 3 additional neutrons. The fission process often produces gamma photons and releases a very large amount of energy.
PayPal works with the tools you already use, like BigCommerce.
Man, I'm dead.
These neutrons are free to split other fissile nuclei, thus maintaining a chain reaction which produces a high level of heat within these fuel tubes. These tubes then transfer heat to the primary circuit water simply by contact. The heated and high-pressure water then flows to a steam generator through pumps and pipes. Within the steam generator, the hot water then passes through a bundle of around 6,000 inverted U-shaped tubes. Then it transfers heat to secondary water in the steam generator. Water in the steam generator is heated to a boiling temperature that turns into steam. This reactor has a set of 3 steam generators and 3 coolant pumps. This pumping process continually runs. This steam then travels to the turbine set to rotate the turbines. Then the rotating turbine turns a massive gearbox. Then its power is transmitted to the propeller. Nuclear submarines carry a wide array of offensive and defensive weapons. The primary weapon system is composed of 20 RSM-52 intercontinental ballistic missiles. The 2 rows of missile launch tubes are situated between the main hulls. Each missile consists of 100 kilotons of nuclear warheads. That is enough to destroy a 1-kilometer radius. The submarine can be capable of firing ballistic missiles from underwater, but the rocket engine needs air to run, so they won't work underwater. So how? How did they launch missiles from underwater? So the secret
Good
is...
afternoon, everyone. Let's close our day with a prayer for generosity. In the name of the Father, and the Son, and the Holy Spirit, amen. Lord, teach me to be generous. Teach me to serve as you deserve. To give and not to count the cost. To fight and not to see the wounds. To toil and not to seek for rest. To labor and not to ask for reward. Save us knowing I can do in your will. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. Thank you to everyone who signed the state and Gopher pledge cards this morning. So far, 80% have signed that card. If you have not yet turned in your pledge card or need a new one, you can pick those up on the table outside the town clerk's office and turn it right back in there as well. Thank you for pledging to be safe and sober. Let's help raise funds for the Notre Dame Friends of Mercy Club. Use the pumps 1 and 2 at the AC, formerly Wings gas station, at the corner of Lexington and Perryville Road, irrigate throughout the month of May. Part of the profits will come back to the club. SBA last overtime event will be tomorrow. Come out and support the soccer and volleyball team. Then join us for faith, food, and fun on the baseball field following those games. Hope to see you all there. The library will close today at 3:10. Any borrowed Chromebooks, return immediately. Have a safe and fun afternoon.
This is full chocolate.
Alright,
Alright, so you guys wanna see how they launch the missiles?
yes.
Is a seal that prevents water from flooding into the launch tube when the missile hatch opens. The weapon system contains 2 compressed air tanks. To launch the missile, they shoot a burst of compressed air to the bottom of the launch tube. Then the air forces the missile out of the tube. Then it breaks the seal at a speed of around 49 miles per hour. It has enough momentum to cut through almost 40 meters of water. Once in the air, its rocket engines are able to ignite. These missiles are capable of traveling around 12,000 kilometers. The Typhoon-class submarine is an impressive feat to behold. From multiple oxygen generation sources and nuclear warheads to modern conveniences like a gym, it is a paragon of achievement in modern warfare technology. With Russia planning to construct at least 2 additional Typhoon-class submarines by 2026, it will be interesting to see the latest developments in technology for national defense. If you enjoyed this video,
Crater. Let's see about that one. Or at least in Moscow is a smoldering crater at the time.
Alright, so that's how submarines work.
We will see.
So hopefully, we don't have a whole lot of submarines attack.
I mean, Norway has to worry about that right now. Norwegian waters have found out Russia's been doing a lot of investigation of state lines, most likely so they can blow up gas lines from under Norway and Finland, since Finland just joined NATO, which would actually be an act of war because that's actually terrible.
flood.
Have a good afternoon, Valerie.
Oh, hey, Beth.
Oh, hi.
Do you have a meeting at 4 o'clock today? I just talked to Emily and she's like, yeah, I have a meeting at 4. I was like, there we go. That's...
I'm gonna go ask Amy Worley and see if she's going. If she's going, she can take care of it. And
Yeah, I just have a feeling this meeting will be short.
yeah. My prescription is ready, and they were not, from what it sounds like, able to fill in terms of 48,000 people coming. But whatever. But yeah, no.
It's really good, Beth.
Expensive home, especially with this weather. So yeah. But definitely also doing something because there's like, it almost feels like trash here.
You should talk to them. What is that? Now she's saying.
I plugged in the thing, I was gonna put the sand in there, but. But I'm trying to get the salt. Right.